Okay, to get this assignment started, I want to do a little bit of background knowledge. In other words, this is what we're going to need. This is our tool chest that we're going to need to go through and do the rest of this assignment in some way that makes sense to us. So there's 3 points that I'm going to bring up here to kind of build our tool chest. In other words, 3 tools, 3 information pieces that we're going to use to get through this assignment. Now, here's the first one. You have to know the difference between the sine and the cosine graph, which I'm pretty sure you do already. This is a sine graph here. And then if we scroll below, this is a cosine graph. And just as a quick review, the way you can tell them apart real easy is if you think about it on a sideways view, this graph from here to here represents more of an S shape that's been turned over on its side. And if you look at the cosine graph below, this more resembles kind of a C that has also been turned on its side. And that makes it easier because cosine starts with C and sine starts with S. So that's the just kind of real quick review on that as far as which one is which. Okay? Let's look at our first true piece of information that I want us to know, our first real tool in the tool chest, and it's this. You have to know the starting points of these graphs. What do I mean by starting points? The starting points, this is tool number 1, is in other words sine. Just plain old sine of x. We haven't done anything to it. We haven't added any amplitude out here. We haven't done frequency. We haven't shifted anything yet. Just plain old sine of x always has a starting point at 0, 0 right here. And if you look at cosine, cosine of x always has its starting point, plain old cosine of x, at 0, 1. So that's the first set of first tool, or first piece of information that we want to know to do this assignment. Okay, let us move on to tool number 2. This, I'm not going to get into a whole lot now except to say this. The period, there's a small formula here that if you know what the period of the function is, you can figure out its frequency by taking 2 pi over b. So that's what this equals here. If you know the period, you can find the frequency. Or if you know the frequency, you can find the period of the function. B is what we will always use in our equations, but knowing one or the other will help us find the one that we don't know. Okay, and this is point 3. Point 3, I'm going to show you in an actual computer demonstration, but I just want to show it to you here with some ink first. The sine and the cosine graphs are extremely closely related. In fact, they both look like one another. They both have this long kind of continuing S shape to both of them. The only real difference between them is where they start, where their starting points are. Sine starts here at 0, 0. Cosine starts here at 0, 1. Now, if you think about it, really all this is me taking the sine graph, and let's say I make a point here on my sine curve, and I shift it over one. What I end up having, and this is a very crude drawing, but what I end up having is a cosine graph. In other words, if I were to graph sine of x into my calculator, I'm going to get this guy here. Sine of x gives me this. But what if I were to take sine of x plus pi over 2? Or remember, when it's inside the parentheses, it's always lying to us. So when we say plus, we think we want to go this way, but insiders always lie. That's what a professor of mine said. So because it's plus, we're actually going to shift pi over 2 radians in this direction. What would that do if I had sine of x plus pi over 2? Wouldn't that give me the cosine graph? Well, what I'm going to do here, and hopefully this guy is working right now. No, he's not. Let me restart it real quick. I'm going to pause this just to say. Okay, we're back in business here. All right, going back with what I said here. What I'm saying basically is if we shift this guy over in the positive pi over 2 direction, which again, insiders always lie, that should give me the same thing as cosine graph. In other words, I just want to show you here how these guys are related. So first let's graph sine of x and see what that looks like on our calculator. Okay, so that's sine of x. We can see we've got a starting point here, and we've got an ending point here. This is at 0, 0. But what if I'm going to disable this here. What if I were to go down and plot the same exact graph, sine of x, but this time I'm going to add pi over 2 inside the parentheses? Would I get a cosine graph? In other words, would it show me something a little different? Let's take a look at it. Absolutely. This is our cosine graph right here. It starts at 0, 1. Now, let me go ahead and I'm going to plot right below that the graph of cosine of x. Now, if these two graphs are absolutely the same, if they are perfectly the same, you will only see one curve. In other words, they will be graphed right on top of one another. They'll be superimposed. And sure enough, in my window here, I have two graphs enabled, sine of x plus pi over 2 and cosine of x. So the whole point for me to do this was just to simply show you that the sine graph is simply a cosine graph that's shifted to the left pi over 2 radians or 90 degrees, however you want to look at it, because they're basically the same thing. Okay, so that was point 3. Sine of x is, we'll say, is related to cosine of x by a simple shift of pi over 2. Sounds like someone's trying to get a hold of me here. Okay, and just conversely, just to show you this again, and hopefully my calculator's still working. Okay, what if I did this? We're going to disable these guys here. Okay. Actually, I'm going to enable sine of x since we've already got that. The same logic follows if we go in the different direction. Here I said sine of x, if we added pi over 2 to it, is the exact same thing as cosine of x. Well, what if I took cosine of x and subtracted pi over 2? Wouldn't that give me a sine graph? Well, let's find out real quick. So all I'm going to do is come in here and subtract pi over 2. Huh, that's a funky looking 2. Looks more like a 5. Okay. And I graph this, okay? So we've got the graph of sine of x. So I'm going to turn this off real quick. Okay, so let's see what the graph of sine of x looks like. Okay, again, what we expected it to be. Now, if I go into my calculator and I enable this as well, again, if they're the same graph, they should just graph right on top of each other. And sure enough, they're superimposed. They're exactly the same thing. So again, that sums up point 3. 1, you want to know the starting points of the graph. 2, you want to know that the period equals 2 pi over b. And 3, sine of x, a way to kind of write this out, is equal to cosine of x minus pi over 2, or you could look at it the other way. Cosine of x is equal to sine of x plus pi over 2. Okay, so these are the 3 tools that we're going to put in our tool chest here, and I'm going to stop this part of it so that we can move on to problem 1. Actually, I lied. This is the other point I wanted to show you here. This is a real-time graph computer program here. So I just went through and wrote up a few things this morning to show you this in real time. Okay, this is our graph of sine of x. In other words, we have our starting point at 0, 0 here. Now, we know that if we shift this over pi over 2 directions, what we end up having is a cosine graph. And let me see if I can do this here without messing it up too much. Okay, simply by shifting it 1.57, which is what you get when you plug in pi over 2, we get our cosine graph. Same thing if we start with the cosine graph over here. if I say to myself, hey, okay, hold on, what if I wanted this to be sine? Well, all I would have to do is shift this over, again, pi over 2 to get it to be sine. Again, I'm only showing you this because the relationship is very important here, and you're going to see how it works into these problems as we start to do them. Okay, this is problem number 1. What I did is just ahead of time, I went ahead and wrote out the equations. Now, they're the same exact thing. A is the amplitude. It's, how far from the middle of the graph to either the peak or the trough. B is our frequency, how many times it goes through a certain interval, in this case 2 pi. That's related to period. C is our horizontal shift. Do we shift our graph this way or this way? And D is our vertical shift. Do we shift our graph this way or this way? That's just a quick review of something I'm pretty sure you already know. Okay, I brought up point 3 in the introduction here for our tool chest, and I said, okay, we know that if we take sine of x and we graph that, that would look exactly the same as if I took cosine of x minus pi over 2. Same thing if I took cosine of x and I graphed sine of x plus pi over 2, they would give me the same exact graph. So why did I take all that time to bring that up to you in the intro? The reason I did that is because of this right here. The basic function could either be sine or cosine. It depends on how you're looking at the graph, but because they're related to each other, it could be one or the other. Some teachers or professors, when they give this assignment, they will tell you, write out the sine function for this graph, or they'll say, write out the cosine function for the graph. But you're not given that choice in this case. You have to write out the function. So what does that mean? If I choose sine, am I wrong? If I choose cosine, am I wrong? No, it can either be sine or cosine, but you have to write the rest of the equation with everything in the right spot and the right signs correctly. What I'm going to do to make this assignment easier for us is I am going to focus on either sine or cosine. In other words, which one can I see the easiest in the graph? And once we're done with the problem and filling everything in, I will simply show you by graphing it that the other one would give you the same graph. So in this case, I'm going to take sine, which means at the end of the problem, I'll show you what the cosine function would look like in its equation, but it gives you the same exact graph. Now, why am I picking sine? Well, the reason is I look here, and I brought up starting points in the beginning. We said that sine typically starts at 0, 1. Well, we know this has been shifted. We can see that already, but it's the similar starting point, and I can see this sine very easily here. So I'm going to pick sine to go with here. All right, so that's kind of our first point, is which one are we going to use? Now, the first thing I want to start solving for, or the first thing I want to figure out, is the amplitude. I know that is listed here at point D, but it does tend to make things a little easier if I find the amplitude first. So remember, we said the amplitude's like kind of basically drawing a line that's straight through the middle of the graph, and we say, what's the distance to either the peak or the trough? Well, since we know that this intersects perfectly, and I believe your assignment is much easier to read than this graph, but these are at every half, which means that's 1, that's 2, and this tick mark here is 3. So if I know that my center of my graph is at 2 here, and I follow the amplitude up, well, that's 1. So that means I don't have to really put anything in for this amplitude for either sine or cosine here. All right, so we've gotten that out of the way. Now what we want to do is we want to figure out the second point here, which is the period, okay? The period, that was the second point in the tool chest here. I said that the period, P, equals 2 pi over B. B is our frequency. Here's the thing with period, when you want to find it so that you can plug in this B into your equation. Find either the period or the frequency. Some of these graphs, it'll be easier to find the period on. Some of these graphs, it will be easier to see the frequency on. It doesn't matter. Find one or the other, and then you can use the formula here to go ahead and work out everything else. So what I'm going to do here is, let's say I look at the frequency first. And the frequency, or let's say I look at the period. Well, what I'm going to do is I'm going to start here since I know this point. And if I take this all the way over to here, that is one full sine length right there. And we said that the frequency was how long it took us to get one full wave cycle for these radians here down on the x-axis. Well, if I try and trace this point back to the x-axis, guess what? It doesn't really help me much because I can't read it very perfectly here. So what I'm going to do here instead is I'm going to try and find 2 points and how many wave cycles there are to read through so that I can get a good solid number. So I'm going to find out what one wave cycle is, which is about right here. This is going to be my second full wave cycle, and this will be my third full wave cycle. And hey, check this out. I've got a clear point to read right here on the x-axis, and I also have a clear point. Now keep in mind the scale on this assignment is these are pi half. They're also 90 degrees. So if I say 90 degrees, I may do that once in a while. Just understand what you're dealing with here. That's pi, so that's 180 degrees. That's 3 pi over 2, which is 270 degrees, and this is 2 pi. Okay, so what this means is I have 3 full wave cycles in a period of 2 pi. I don't know why I wrote 2 pi over 2, because that's not correct. So what that says is my frequency, B, is 3. So since I'm looking for B to begin with, I can go ahead and put that in for this, but I need to find my period still. Well, we said period is equal to 2 pi over B. Since I know my frequency, all I got to do is plug that in, and I get 2 pi over 3 for my period. Okay. So the max and mins, we'll leave that for last, even though I know you're looking right at it as kind of in between here. Let's go ahead and do the vertical slide, because that's going to be this D part here. So what I say for the vertical slide is, first off, the amplitude hasn't changed, so that's going to help me figure this out. But I know my starting point should be down here. So if I had a sine graph originally, and this, again, is a very terrible graph. This isn't drawn to scale. It's just to show you for the amplitude shift, or sorry, the vertical shift here. That means I have to shift this up 1, 2 to get this starting point up here. So I know my vertical slide is 2, and because I know it goes up and it's on the outside, it's going to be a positive 2. Okay, we can actually write our equation out now. There is no amplitude here, and I'm just going to go ahead and do this for the sake of being complete so that we can see this as much as humanly possible. We know there's no amplitude, or, well, let me rephrase that. We know the amplitude is 1. There's no real reason to write 1 times sine here, so I'm not going to worry about that. So I know I have a sine function here. Now, we already said the frequency was 3, so that's going to be 3x. Now, did we have a horizontal shift? Well, no. The starting point is here and here. If it had been shifted out in this direction, then we would have had a horizontal shift. And you'll see that in a few problems here. Even though there wasn't a little category here for horizontal slide, we will have them, and you'll still need to know them to plug it in for this term in the equation. But in this case, we don't have it, so we're just going to leave it alone. We're not going to put plus 0. We could, but there's no reason for it. Okay, vertical. That is plus 2. So what I'm saying to you is, if I'm reading this right, and I'm using all of these steps here to do this thing correctly, I should be able to plug in sine of 3 times x plus 2 and get this exact graph. So what I'm going to do real quick is bring up the calculator and see if this works out. Okay, so I'm going to take my sine function here. I'm going to put in 3x, close the parentheses because there's no horizontal shift here. Then I'm going to add 2. And if I graph this guy, what do I get? Well, let's compare it. We're crossing at the same point. We have an amplitude, or the peak is at 3 on the y-axis here. I should probably bring that up again. And if we look and compare this, we have our first trough at pi over 2, which we have here. We have our peak. Well, we can look at this one. This is an easier one since we know it's an exact value. That third full wave cycle ends up at 2 pi here. So we know this is exact. Now what I also want to do is just show you what this looks like with cosine having graphed it, just to show you it could be the other way around. I'm not going to get into the explanation as to why I did it, or I'm sorry, how I did it. Okay, I plugged this in already into the calculator just to show you what it would look like. So I've got both of these enabled here, and remember, if they are the same exact graph, they will be superimposed. You're not going to see two separate graphs. So let's just graph it real quick, and sure enough, it's the same exact graph. So if I go back here and I turn this guy off and graph it, you see it's the same exact graph. If I come in here and I do the same for this guy here, and then I enable this one again and graph it, same thing, okay? If you want to take a look at this, this relates back to that third tool I was talking about over here. These graphs are related because they're simply shifted in one direction or another by pi over 2 radians, or shifted in one direction or another by a factor of 90 degrees, okay? It's the same exact thing. If you want to look at this more and try and figure it out, that is yours to do, but I'm not going to focus on that too much. Again, what I want to do with this is I want to try and find the easiest thing to see first. And if you want to play around and look around and say, okay, well, what would be the cosine one? Go for it. Have a blast. But this is just to show you it could be one or the other. And let's finish this up. So I know I've got my equation here. Max and min should be real easy to find here for you. It's going to be 3 over here, and it's going to be 1 over here. So your minimum value for your y-axis is going to be 1. Your maximum is going to be 3. Okay, let's move on to problem 2. Okay, this is problem 2. We're going to proceed in the same direction. I kind of messed something up when I did the intro and I was doing out the tool chest. I said we had 3 things we wanted to remember. There's actually a 4th thing, and this problem made me think of it again. So I'm just going to show it to you when it comes up. But keep in mind, I'm going to show you one more tool. Again, I knew I was forgetting something in that intro, but I'll plug it in here, and then you'll be able to see it used throughout the rest of the problems. Okay. First thing we said is decide what we want to use. What looks easiest for us to see here? For me, cosine is easiest to see here because I can pick this out as a starting point, and even though I can't see my end point, which would be over here somewhere, I do see the halfway point for that cosine function. So I'm going to go ahead and use cosine. Again, at the end of the problem, I'll show you what the sine function would look like, okay? But let's focus on what's easiest to see. Okay, first thing I said we should probably try and do is find the amplitude. So in this case, we kind of take the halfway mark between the peaks and the troughs, and we say, okay, what's the distance? Well, it's 1. So our amplitude is 1. We really don't have to worry about plugging that into our equation here for A. Now, our second thing is we want to figure out what the period is specifically so that we can figure out what the frequency is. We know our little formula here is 2 pi over the frequency for period. Again, I said try and pick out the one that's easiest for you. You'll either be able to see the period real easily, or you will be able to see the frequency very easily. So what I'm going to do here is I'm going to start with trying to find a point on the x-axis that matches up perfectly with points that I know on my cosine graph. Now I can see at the starting point here that this gives me negative pi. And I can see in the middle point here that this gives me positive pi. That means 1/2 of a full wavelength is 2 pi. Now, again, since I've got my other point somewhere over here, and I know this is a distance of 2 pi for just half of this wave, I know that I'm going to have 2 pi again for the other half of the wave. That means my period will actually be 4 pi. Now, we do need that information so that we can plug it in here for this table, but what we really need to figure out for our equation is what B equals. So, since I know period is equal to this, and I already know what the period is, I'll just set these equations equal to each other. And by doing some algebra here, I multiply both sides by B. That gives me B times 4 pi equals 2 pi. Divide both sides by 4 pi. And B gives me, well, the pi's cancel out, and that reduces to 1/2. So I know that my frequency is going to be 1/2. Now, we can fill in the max and min right now if we want to. We know these are 0.5 interval tick marks here, so that's 1. That would be 1.5. So you can write that as a decimal if you want, or you could write it as a fraction. It doesn't really matter. The minimum value here is -0.5 or -1/2, depending on how you like to write it out. Now, our vertical slide. Well, let's see what we've got here. Let's clean this up just a little bit. I know that my starting point should typically be right here. And I'm not drawing this out to scale. I'm just drawing this part of it really just to show, okay, it ended up right here. So how far do we have to shift this up or down? And it only turned out to be 0.5 units. So for my vertical slide, I have positive 0.5 or positive 1/2, however you want to describe that. Okay, what we need is our horizontal slide. This is also known as the phase shift. That's its technical term. The phase shift, this is point 4 that I should have brought up in the intro when we were talking about the tool chest. Once a graph like this has either its amplitude changed by either being stretched out or by being compressed, and same thing for its period or frequency, if this thing is stretched out or it's compressed, what can happen is this can make you think that it's been shifted over a certain amount that it really hasn't been. Because the graph is now distorted, it's out of shape that it used to be in, this can make us look at certain things here and say, okay, well, let's just use this as an example. If I look over here and I know that this should be my starting point, to me, I know that that is -π/2, and I know that that's -π at this point. To me, I want to say, okay, well, shouldn't that be +π for my phase shift, for my C over here? You would think so. But point number 4 is a big deal. Let me write this here. The units shifted, as you see it on the graph, like here, that's 2 units shifted, which we know is really π, equals C over B. We're going to use this the same way we use the period function, or the period formula. In other words, this has been shifted over from its original starting point, π units, the way it's written right now, the way it looks to me, but we know that this graph has been distorted. We know that it's been stretched out. So we don't want to rely on that because it's going to give us a wrong answer. So if I know that it's been shifted over π units, I already know what B is. I know B is 1/2. That gives me C over 1/2. If I multiply both sides by 1/2, it'll be real easy for me to figure out what C is. C simply gives me π over 2. And I know it's been shifted in the negative direction, so what that phase shift is really going to be is positive π over 2, because we know that whenever we're dealing with something that is inside the parentheses, my professor always used to tell me, insiders always lie, kind of like crooks at a corporation. If you're an insider and a cop comes to interview you, there's a good chance you're lying because it was probably an inside job, whatever bad happened at the corporation. So our insiders lie. We know that this shifts over in the negative direction, but that's going to give us our positive sign. Now we can go ahead and write out our full equation here. We know that the amplitude is 1, so we don't have to plug that in. We're dealing with cosine here. Now we know already that B equals 1/2. It's been stretched out. So 1/2 x. We also know from using our little tool over here, the unit shifted equals C over B, that this really, when we plug it into our calculator, the phase shift should be π over 2. And we've already seen that it's shifted up plus 1/2. I don't know why I'm writing pi here. Plus 1/2. So what we're going to do is plug this into the calculator real quick and show you how it works. Okay, So I went ahead and I plugged this in already on the calculator just to save us some time, since this thing's going to turn out to be really long anyways. Same thing we wrote down here. We can compare it out. This is what we wrote. This is what we have up here. Cosine times 1/2 of x, plus pi over 2 on the inside, plus 0.5. If we graph this guy out, we get a graph that looks exactly like what we started with. Now, what I want to show you is what had happened if I looked at this first without considering our fourth tool here, the unit shifted, pi unit shifted over equals c over b, if I had plugged in pi right here instead of pi over 2. You'll see that you'll get a graph that doesn't look the same. So the first thing I'm going to do is just disable this so that we can see the other graph. Okay. I would use cosine 0.5 x plus pi plus 0.5. So we graph this. Is it going to look the same? We already know it's not, but I still want you to see it. You can already see this looks nothing like that. So this fourth tool over here that I showed you is an important tool to keep in mind. All right, and let me just show you what what sine would look like here, just to kind of make things, just to show you again that it's kind of your choice. I just choose the easier one. If we used sine, we would have sine of 0.5x, 1/2 x. I could probably clear that. Actually, no, I'm going to leave that. Plus pi plus 0.5. Okay. So again, I told you you could use either sine or cosine, and again, you can already see there's just a difference of pi over 2 here. That's the only difference when you're switching over. But if we graph this, we have a graph that looks like what we started with, and as you can imagine, if I enable this here, the graphs will superimpose each other, which shows you it's exactly the same graph.